Today we are talking about conjunctions.
Conjunction.
Whoa. Whoa. Conjunctions.
Whoa.
So that's a word you might have heard from like English or something. What's it mean in English? And or but. Okay, in math it means and. It just means and in math. So, and by and means, I've defined and. The first thing you say is true, and the second thing you say has to be true, both together. Like if I say you guys are freshmen and you're in Algebra 1, I know you're not all, but I'm implying both of those are true, right? As opposed to or, which means maybe just one of them is true. So and implies the two things together, the two clauses have to be true. Yeah, it's called a conjunction. The symbol for conjunctions looks like this. So it kind of looks like an A, but this is the symbol for it. Okay. Let's start with, there's kind of three cases that could happen today. We're still talking about inequalities, by the way. This is still the inequality chapter. Let's do x is greater than 2 and less than 5. So what does that imply? X is greater than 2 and less than 5. Okay, here's how we're going to do it. A lot of these are going to be graphs. Greater than 2 looks like this, right? That's what greater than 2 looks like, all those numbers. Less than 5 looks like this, all these numbers. Okay, but where are they both true? What numbers are greater than 2 and less than 5?
3 and 4.
Well, not just 3 and 4, although that's part of it.
2.5, 2.6.
All the infinite decimals and fractions that are between 2 and 5. So when it's an and, it's where they both are true, right? I said they both have to be true. Where are they both true at? All right here. All this stuff. Whoa. All this stuff right there. Okay, so not just 3 and 4, but everything between what? 2 and 5. So on the graph, 2 and 5 are not included, just like they're not included up here. It would look like this. Okay, this is not actually, this up here is not the, shh. This up here is not the answer. This is like me showing my work, kind of, just to figure out the answer. Everything between 2 and 5. By the way, this could also be written as all the numbers between 2 and 5. The better way to write that, you guys are going to see this a lot in high school, looks like this. This implies that x is greater than 2 and it's less than 5. So it's everything between 2 and 5, like that. So far, so good?
Sure.
That's possibility number 1. Possibility number 2.
So that's how the graph would look.
That's what the graph would look like. All the numbers between 2 and 5.
The answer.
I might go a little bit neater. If it's a graph, it would look like that. I guess if they wanted just the numbers, we could write it like that. Not all of these are graphs. Some of them are just solving. You'll see in a bit. Okay, case number 2. They're kind of going the same direction. X is greater than 2 and x is greater than 5. Maybe you guys can figure it out before I do it. So x is greater than 2 would be all these numbers. This means and right here. And x is greater than 5 looks like that. So what numbers are greater than 2 and greater than 5?
Every other number, everything comes to 5.
Right. It would have to be all these numbers out here. Because is 4 greater than 2 and or and greater than 5? No. It's gotta be both. So it's where they're both at. Where are they both at? Everything past 5. So the final answer would just be that. Like x is greater than 5, basically. Okay? So if they're going the same direction, only one of them really ends up being the answer. Okay, and the last one, this is kind of the weird case, is x is less than 2 and x is greater than 5. What numbers, you guys maybe figure it out before I tell you.
3.
What number is less than 2 and greater than 5? Okay, what's less than 2 look like?
1.
What's greater than 5 look like?
5.
What numbers are both of those? Because it's an and, it's got to be both.
4. 3 and 4.
None.
Oh.
Okay.
This is 0.
So the graph would be blank because there's no solution. You guys know the fancy way, right? No solution?
A circle with a line in it?
Yeah, circle with the slash. So if we're graphing, I guess you just put a blank graph. They'll probably ask to graph once. Or if it was a problem that we solved, we could just write no solution like that. Okay, those are kind of the three. The problem is tomorrow we're doing something called disjunctions, which means or. And when we jump back and forth between and or, people get confused. But maybe today will be okay. We'll see. We'll see how it goes. Okay. Page 160 says graph. So 1 through 6 we're graphing, the rest of them we're just solving. Let's do it like I was doing it. We'll put the floating lines above the graph to figure out what it's supposed to look like, then we'll put the final answer right on the graph. So number 1, it's got a 2 and a 4 on it, so make sure your graph at least goes between 2 and 4. I mean, you can do it a little bit bigger, 1 and 5. Okay, what does x greater than 4 look like?
A circle over 4.
Going to the right. All the numbers greater than 4 are to the right. Bigger numbers are that way. And then what is x is greater than or equal to 2?
A closed symbol over 2 going to the right.
Going to the right. All right. So was this one kind of like example 1, 2, or 3?
1.
It's like my example 2. So what numbers are greater than 4 and greater than or equal to 2?
In between those?
Okay, the ones they have in common are all these numbers, which is basically what? Everything past 4. Is 4 included?
Yes.
No, because it's not included in this one. Is 4 greater than or equal to 2 and greater than 4? No, it's not greater than 4. So 4 is not included. Basically, if that's an open circle, that's an open circle. Or if that's closed, that's closed. And then everything out that way. So this is the final answer. This is just me like showing my work. This is the answer. All right, number 3.
Is 5 inconclusive?
Inconclusive wasn't an option.
X is less than -1 and x is greater than or equal to 4.
Yeah, I see it. All right, number 3. -3 and 1. All right. What does x is greater than -3 look like? Kind of like these two, right? Because those were both greater than. So greater than -3 looks like that. And less than or equal to 1. So remember the arrows kind of go the same direction as the inequality. So 1 is closed, going to the left. Notice I drew my arrows pretty long so you can kind of see where they overlap. Okay, what numbers are both greater than -3 and less than or equal to 1? All the ones in the middle. So this is kind of like my example 1 from the start. So what should I graph though? All the numbers between -3 and 1. Are -3 and 1 included?
No.
-3 is not included, but 1 is. 1 is in both of these. It's in this one and this one. So 1 is included. So, and then just, let's connect the dots in the middle. Do not go past the dots. Okay, number 5. Was this one Brian was asking about? You have to wait for the Germanic. -1 to 4. -1, 0, 1, 2, 3, 4. Okay, so x is less than -1 would be an open circle at -1 going left. All the numbers less than are that way. And x is greater than or equal to 4. Closed circle at 4 going that way. So what numbers are less than -1 and greater than or equal to 4? Nothing. They don't have anything in common. And means it has to be this and that. There is nothing that is less than the -1 and greater than 4. So we'll just leave it blank.
Circle with a line.
No, just blank. The line implies that's part of the answer, and there's nothing part of the answer. Like not even these things are part of the answer. So anyway, it's just a blank graph. Okay, number 7. We're not graphing these, but yeah, let's jump in here. 2x is greater than -6. And x is less than or equal to 1. All right. Well, there's 2 separate inequalities, right? We're combining 2 inequalities. The inequality on the right over here is already simplified. It's already as simple as it gets. X is less than or equal to 1. We can't do anything with that. But on this one, we need to figure out what x is. So how am I going to solve for x on this one? Divide by 2. Is the inequality going to switch? No. So I'm dividing by a +2. Okay. If this were an even, I'm going to let you guys stop there. But technically this is not the best way to write the answer. So we're going to, since I'm helping, we're going to simplify it. What numbers are both greater than -3? Might think about it on the number line in your head, if you can imagine. What numbers are greater than -3 and less than or equal to 1? All the numbers between those two. All the numbers, how do we write the numbers between -3 and 1? You put x is greater than -3 and less than or equal to 1.
So do we need to do this on all of them?
Okay, I said on the evens, I will let you guys stop here. But really this is the answer the book wanted, the simplified version. Notice I'm kind of saying the same thing. See how that looks the same? X is greater than -3 and less than or equal to 1. kind of saying it all in one line. Yeah. Number 9. We got two different things to solve. Where did we leave off yesterday? Don't remember.
I'll start.
Was it here? It's Bo.
He went, so he went.
Oh, okay. I thought you were throwing Bo under the bus here. You're like, it's Bo. Bo was the last one to go.
Yeah.
I lost my place.
9.
9. Negative 5x plus 13 is greater than negative 7. So we just got two different things to solve here. Both of them are kind of basic. 4x minus 6 less than or equal to 10. Okay, Jonathan, what could we do to solve this left one?
It would be subtract 13.
Subtract 13. Kind of like yesterday, it's just kind of basic stuff. Negative 7 minus 13 is negative 20.
And then you divide by -5.
And the sign would switch.
Okay, the sign switches. How about this one?
And for that one, you add 6.
And then you divide by 4. And the sign stays the same.
This is a kind of a weird one. What numbers are, okay, now again, if this wasn't even, I'd let you stop here. But on the odds, let's clean it up a little bit. What numbers are less than 4 and less than or equal to 4?
9. All under numbers in the
Okay, okay, let's start with the obvious one. Is 5 less than 4 and less than or equal to 4? Is 3 less than 4, less than or equal to 4?
Yes.
Yes. Is 4 less than 4 and less than or equal to 4? No. Okay, 4 does not meet this qualification, so it's really all the numbers less than 4 are going to work. This one would include 4, but this one doesn't, so 4 is not included, so it'd just be x is less than 4. Number 11. All right. X plus 12 less than 18. Okay, Sophia, what do we do when we have x's on both sides over here? Right, and how do we get rid of them off of one side?
Minus 2x.
Okay, yeah, we want all the x's on the same side, so if you subtract 2x over here, that cleans up the left side, but then you have to subtract 2x over there. So, we got 2x, so we have to divide by 2. Inequality does not flip, because we're dividing by positive 2.
Is there gonna be decimals in this?
I don't remember. I didn't really look. Let's do fractions instead of decimals. Okay, so this is the answer. Do you guys know how to read this one? How would you say this one?
negative
Negative 2 is less than or equal to x, or x is greater than or equal to negative 2. So bigger than or equal to negative 2 and less than 6. What would that include?
all the numbers in the middle.
Right, that would be between the two. bigger than -2. So the final answer is gonna kinda look like this combined. It's greater than or equal to -2, and at the same time, it's less than 6.
Wait, so I have a question on number 9. How'd you get x is less than 4, or is it?
You mean, how did I get this from this?
Yeah.
What numbers are less than 4 and less than or equal to 4? Well, these two are almost identical. The only difference is this one does not include 4, but this one does. So if this one doesn't include 4, then 4 doesn't count. So anyway, it'd just be all the numbers less than 4 meet both of those qualifications. If we were to graph it, less than 4, less than or equal to 4, what do they have in common? Just all these numbers over here that are less than 4. They don't have 4 in common. Alright. Anyway, let's see. 15. One of the evens is, okay, never mind, we don't have to worry about that. 13, x minus 3 less than or equal to 4. And 2x plus 6. Alright, Hank, what would we do on the left one? It looks like number 11.
Number 13.
Yeah.
Would you divide by 4?
No, if you have x's on both sides,
You subtract x.
subtract x to get rid of it on one side, that go away. 4x minus x.
3x. And then the other side. Oh, wait, we're just on one side first.
Divide by 3. We're trying to get x by itself, so get rid of 3 by dividing.
Then on the other side, we do minus 6. And then you divide by 2.
Okay, so very similar to the last one. What numbers are greater than or equal to -1? So bigger than -1. And less than 6.
All those in between.
Right, all the numbers between those two. So how do we write that? So notice on this one I did include -1. It's less than or equal to -1, just like this sign. And on this one I did not include 6, just like that sign. By the way, this could also be written backwards. You could say 6 is greater than x is greater than or equal to -1. That would be the same thing. Yeah. All right, 15. We're getting there slowly. 19 is weird. Okay. All right, Avery, what should we do on this one? same thing, subtract 2, divide by 3. Alright, how do we simplify that? What numbers are less than 3 and greater than -2? So -2 bigger, 3 less, it'd be all the numbers between again. This time -2 is the small number, right? So it's bigger than -2 and smaller than 3. Alright. 17. I might have to get it on the video, or just do it yourself. It's not that much to it. 4x. Okay, Manny, on number 17, what should we do first?
You first combine like terms, 4x minus 5.
Right. So I'm going to do that one in my head. 4x minus 5x is negative x, like negative 1x. So that minus 2 is greater than 10. And 3x minus 6 is less or equal to 12. So Manny, what should we do to solve this first one?
You'd add 2.
Add 2.
And then you divide by -1.
Divide by
Sign
negative.
switch.
Divide by -1, and you said the sign switch, which means the greater than becomes a less than. Also, the positive negative sign switches. 12 divided by -1. Okay, over here, got the minus 6. This one might confuse you guys, maybe the cleanup answer. What numbers are less than -12 and less than 6?
None.
Hmm?
None.
No. Is,
I don't know.
let's say is 0 less than -12 and less than or equal to 6? No. 0 is not less than -12.
X is less than negative.
Right. What numbers are less than -12?
Negative
-13, -14, all those numbers. So only those numbers would be less than both of them. I can't use like 5, 4. Those would be less than this one, but they're not less than. So we have to use the this kind of the limiting qualifier. This one is more particular than that one. Anyway, all the numbers less than -12 would work as the final answer. Again, on the evens, I'm going to let you guys stop on the second to last line. All right. 19, this one's really weird. There's nothing to solve on this one, we just got to simplify it. X is not equal to -3 and x equals -3. So, what do those two have in common? What numbers are equal or not equal to -3 and equal to -3? Nothing. That's contradiction. You can't be equal to -3 and not equal to -3. So the answer is
Every other number.
no solution. No answer, yeah. You could use the symbol or you could write the words, no solution. Okay, 23 and 24. Probably should have done a couple more of these. Looks weird, but it's not actually that bad. Okay, should have probably done a couple more of these examples. So what we want to do to solve for x is we want to get x by itself in the middle. You guys see how there's a left, a right, and a middle? So how am I going to get x by itself in the middle here?
Add 4 to both sides.
Well, not
Or subtract.
subtract 4. Okay, so yeah, the weird thing though is now we have to subtract 4 to... It's really like two things in one, like we're doing this one and this one at the same time. But yeah, you gotta subtract 4 to all three sides. Yeah. So this one's -6. What's gonna be in the middle? Just the x. And over here is 7 minus 4, 3. That's all. Alright, still got 12 minutes. Good luck. I'll come around and see if you got number 2 right.